Hello everyone, this is Bharatoj Reddy and this is my DA2 NATO Tetris project too. And we'll see what we'll learn in this. So what do we learn in this? We'll learn how to make a computer from scratch, how to use basic Boolean logics to create a computer, how to learn about NATO Tetris, hardware simulator, and also about HDL based simulation. So what goes making inside microchips and microcontainers? So it starts from the assembler. Assembler goes to the computer architecture, the abstraction point, and then it is followed by digital system and design. It is then sent to CPU, RAM, and chipset, followed by gate logic. Gate logic is where this AND gate and NOT gate, all these gates come into action. Then followed by elementary logic gates, and then to the electrical engineering, and followed by the components used. So binary numbers. What are binary numbers? A computer doesn't understand a complicated language that they give us input. It converts all our given commands into binary numbers such as zeros and ones. So how are binary numbers represented? So basically binary number 0 is written as decimal 0. Binary number 1 is decimal 1. And binary 10 is 2. Binary 11 is 3. And 100 is 4. It's written by two power form. We'll study it in the next slide. Yeah, how to convert binary to decimal. A system using only converting binary to decimal. You need to multiply each digit by its corresponding power to add zeros and ones. So basically, you take the example as 1010. So will come from the left hand side. 0. So we just multiply 0 with the 2 power 0. 1. 1 into 2 power 1. And the digit from the left, 0 into 2 square. That is 0. And the 1 into 2 cube. So we do it by using the decimal equivalence. And decimal to binary, divide the decimal number by 2. Get the remainder and repeat. So we took here the example as 17. So when 17 is divided by 2, gives a reminder as 1. So we take the first number as 1, and next we follow by doing the simplification. We get it as 100 10001. Next, like binary addition. Binary addition follows four conditions. 0 plus 0 is equals to 0, 0 plus 1 is equals to 1, and 1 plus 0 is equals to 1, and 1 plus 1 is equals to 0, and a carry. So this is the example for the binary sum. We took triple zero one, double zero double one, double one zero one plus this number. So in the RHS side, 1 plus 1 gives 0 and carry 1. So it becomes in the second thing, it becomes 1 plus 1, 1 carry and 1 down. Here it becomes triple one. Triple one is basically 1 carry and 1 as a remainder, and so on. This is how the addition is done in binary numbers. So half adder. A logical circuit performs the addition of two binary digits, output sum and carry. This is basically the half adder example diagram. And full adder consists of adds three binary digits, output as sum and carry. This is the example of full adder. ALU. What is ALU? ALU is arithmetic logical unit. An ALU is a digital circuit performs an logical operation on binary numbers. Non-human architecture. This is a non-human architecture diagram. So basically input is given, it is stored in memory, it is sent to the CPU which contains ALU and the control panel, and then from the ALU it is given back to the output, and if any changes are made, the ALU gives back it to the memory where it is stored in the computer system. The arithmetic logical unit, ALU. The ALU computes a function of two inputs and outputs as a result. So basically, it takes the two inputs and gives a single output. Arithmetic operations such as it performs arithmetic operations such as addition, multiplication, division, etc. It uses logic operators such as AND or XOR. These are the diagrammatic thing. So hack ALU. To cause the ALU to compute a functional set, the control bits to the value are listed in the tool. So these are basically the control bits which we'll do in the simulation part, and these are the outputs we get in our simulation. This is an illustrative diagram. So let us do the simulation part. First you open the tools, then you open the hardware simulation. You select the chip name as ALU, load the chip, just put it side by side. So here we got X, Y, X, Z, N, X, Z, Y, N, Y, F, and N naught, like the control bits over here. So what we do is we give the inputs. First, we'll do the first three examples. So here the X, Z is 1 and Z is 0. X, Y is 1. It's 1, 0, 1, 0, 1, 0. Okay. And F is 1. Give the inputs X and Y as 0, 0. And yeah. We got the output, we can see here we got the output as 0 as shown in the diagram. Like, if we change the inputs also, there will be no change. So we give here 1 and there will be no change in the output because the output depends only on the control bits, not the input and output. And coming to the second one, it's all the control bits are of 1. So the control bits are of 1. Mhm. 1. Save it. Yeah. When we give all the inputs as 1, I mean the control bits as 1, we get the output as 1, which we got here. And if it doesn't matter the values of x or y, so suppose we give it 0 and we do the same. Okay, yeah, the output doesn't change as it depends only on the control bits. The third example is 111 0 1 0. So 111 0 plus 0. Yeah, in the simulation we got the -1 as the output. So we change the x and y value. We give here 1. We give here 1. Yeah, there isn't any change in the output value since it depends only on the control bits. And this is all about the assignment. Thank you.